of that, however, there's something very, very important to remember, which is what we're going to spend, 99% of this class on, or let's say 90+%, is actually only 10% of what people who do, data mining, analytics, machine learning in practice spend their time on. And it's very important to be aware of what the other 90% of it is. Okay? Because, if you become a data analyst, this will be, chances are, what you spend most of your time on. So what are those things? Well, let's say you have a problem, right? You're in a company or you're a scientist, you have some phenomena that you're trying to understand, you have some prediction that you're trying to make. Like, you want to design better drugs, right? You want to design a vaccine for AIDS, right? This is, of course, a very real example, right? What is the first thing that you have to do? It's not to get out your machine learning, suite. The first thing that you have to do is understand the problem. Understand the domain. Learn the biology. Learn the marketing. Learn natural language if you're going to do document, processing. Okay? This is where talking to experts is very important. Usually a machine learning project involves at least two people. The machine learning expert and the domain expert. In some cases, these two people are the same, but that's a very, high burden for one person to bear. You might be working in collaboration with a doctor who has the expertise about AIDS, or in collaboration with a marketer, or in collaboration with someone who's an expert on finance. Okay? They have to learn some machine learning to talk with you. You have to learn some finance or medicine or whatever to talk with them. Okay? And you also have to understand what the goals are. Right? Because there's no point in understanding the domain if most of it is irrelevant to the task at hand. And sometimes the goals are very clear, right? This is a hedge fund, you're a quant, right? You have $10 million, invested. Learn to predict better than chance whether, stocks in this sector go up or down. And if you do that successfully, you'll be rich. And if you don't do that successfully, you'll be fired, right? In that case, the goal is clear. More often, actually, what happens is that the goal is extremely unclear. The goal is like this, like I'm the CEO of a company and I know that we have a lot of data. We have tons and tons of data on our customers coming every day to our website, and I have the feeling that there's enormous value in this data. If only I could mine this data, I could make decisions better and beat my competition, but my competition is ahead of me in data mining and we got to catch up with them. Please do something. Do something is not a very clear goal, right? In some ways this is a harder problem. In some other ways it's actually a great opportunity for you, like go to town, right? Have fun, figure out what there is to do. When I talk to people in industry, like people who do machine learning at these companies, the number one thing that they always say is, we have more things to try than we can. Right? They only have so many thousands of people in the company, and some companies, a good chunk of the engineers are people with expertise in machine learning, but they have too many things to try. Right? So go and discover where in the company is the value to be created. Either way, it's very important to understand the problem, the domain, the goals, the constraints that you're going to be operating in, right? Certain things might be very good machine learning, but might not be deployable, in which case, you should think about that before you get into them, okay? So this is step one. Step two. Sounds very boring and banal, but this is often the single most time-consuming step. You got to get your data. Remember, the reason we can be lazy is that the data is going to do our work for us. No data, no learning. Big data, big learning, that's where the opportunity is, right? The reason machine learning is taking off like gangbusters is that we have more data than ever. Does this mean that our life is easy? Actually, no, this means our life is hard. Dealing with more data is harder than dealing with less data. At the end of the day, you might be able to learn a much better model, but you have to, and the thing is that the bigger the data is, the crappier it is. This is like Murphy's Law of machine learning. The more data you have, the more it sucks. In the old days, somebody would do an experiment in the lab, very well controlled, would have 1,000 data points with 10 dimensions each, but it was like sparkling clean data. These days, instead of those 1,000 data points, we have 1 billion, and each one of them has 10,000 dimensions, but half of it is garbage. Half of it is people who put in their birth date as being January 1st, 11/11. Half of it is incompatible formats got munched together, right? So you got to take you have to find your data, you have to clean it, you have to integrate it. You often have multiple sources of data. In all large projects, this is always the case. You don't have a single source of data, you have multiple sources. often from very different origins, and you have to put them all together. And if you put them all together wrong, garbage in, garbage out, right? Your learning program is going to learn the stupid things that happen because of what you put in the data, right? For example, I know an example where the program learned that men get pregnant because somebody merged the fields wrong, right? That kind of stuff happens, okay? So cleaning the data, pre-processing it, integrating it, selecting what's most important is a very big chunk of all of this. Finally, you get to what's usually considered the fun part. And again, if you talk to the people who do this, this is usually the part that they really like to do, which is to learn the model, right? This is where the fun begins. You do discovery. You're like a scientist, either really a scientist or the equivalent of a scientist in industry, right? This is when you get to discover things and, follow hints, be a detective. And this is where we have a lot of great technology for you to use. This part is very mature. Part of the reason why it's very mature, of why we're going to spend almost all our class on it, is that we can come up with very general techniques that you can learn in this class, and then you can apply to 100 different things. And tomorrow there'll be 100 new things that you can apply to that today we haven't even thought of them, right? So here we have very general tools, and they're pretty mature, so this stuff works. Part of the reason why this often doesn't take most of your time is that it's pretty good at this point, so using it actually doesn't have to take that long. Okay? It depends on how accurate you want to get, right? You could spend a long time on this, getting ever more accurate at predicting, what things people are going to click on and whatnot. But in many ways, this is the most efficient part of the whole process. After you've learned your models, you are not done yet. You have to understand them. There are some areas where if your model works, people are willing to close their eyes and let you use that. One of these areas is finance, in some cases at least. Nobody really, at the end of the day, understands how the markets work. If your algorithm, no matter how opaque it is, reliably predicts something better than chance, well, it's making money. We'll take it. We'd prefer to have something we can understand, but if we can't understand it, but it's making money, we'll live with it. For most problems, however, if people don't understand what your algorithm produces, they will refuse to use it. You don't want to tell somebody, you need surgery because you have breast cancer. Why? Because this complicated nonlinear function with its coefficients is outputting plus 0.5, which is above threshold. This is not a very persuasive thing to tell a patient. Or to tell the CEO of a company if you want to persuade them that there's a different market segment that they need to address and whatnot. Remember, you're probably going to be in the room with experts who are very convinced of their expertise, and often your learning algorithm will tell them, like, I'm sorry, but your marketing knowledge is wrong. We know better now. And they're going to say, this box of junk is telling me that I'm wrong. No, right? I know of many examples where people had very accurate machine learning algorithms that were not used because of this. And just to give a random example, right? You can use machine learning algorithms for wing design. But, if the wing flies and then whatnot and has the right, envelope of characteristics, people might be satisfied with that, but hell no, right? They want to be convinced that that thing is safe, right? And if it's just some black box neural network that produced this design, they're not going to take it. The second reason why interpreting results is very important, more subtle but equally important, is that this whole thing is not a one-shot process. It's a cycle. And you need to understand what your algorithm is doing in order to then go and improve it. The machine learning algorithm is doing this very large search, right? That's what the computer's for. It can do all this hard work by itself. But the outer loop involves you. It involves you tweaking the algorithm, trying different things, and again, this is what people spend a lot of time with. But it's very hard for you to tweak the algorithm or try another algorithm or maybe bring in a new source of data because that's what was missing if you don't understand what the algorithm is doing. Okay? So it's very important to understand the results in order to make that loop converge to the point where it's doing something really good or at least good enough. Okay? So this whole set of things is really not a linear sequence of steps, but it's loops within loops, right? From interpreting results, you might want to go back to learning models, or you might realize that you need better data. When learning the models, you might realize that you need better data. This whole process might lead you to a better understanding, and based on an understanding, you're going to do a whole bunch of different things now. Okay? So this is how things actually work in practice. Finally, let's suppose you came up with a crackerjack model, right? This thing works, amazingly well. Are you done? You're not done. The majority, I don't have a firm statistic on this, but I'm willing to bet that the majority of machine learning projects that were successful, in the lab, if you will, actually wind up not being used in practice. because there's, as with anything else, right? Between your product and people actually using it, there's all these things that have to happen. There's all these stakeholders that could say yes or no, that might help it or hinder it. Things might have changed on the ground while you were learning your model. And these things are all getting better. So I think the hit rate is actually improving. But the key thing to remember is that your job is actually not done. You can't just go to your boss and say here's the model, now use it. You actually have to make sure that the people who have to use the model will be willing to use it, or that this thing will get deployed in whichever way it needs to get deployed. The deployment could actually have the form of here's an example, right? Donnelly, the largest printing company in North America, right? They actually had at one point the result of this was a decision tree. What they actually created was a piece of paper that got, pasted onto the machine saying, if this reading is this and that reading is that, do this. This was the deployment. Of course, these days often the deployment is you have an algorithm on a website that is predicting, if you bought this book, you might want to buy that book as well, right? But it has to work at that level, number one. And then number two, it has to keep on working. The world keeps changing. The phenomenon that you're modeling might have changed. Also, the data might have changed. Your algorithm assumes that the data is coming in this form, but now the data has changed to that form, and now things start to go haywire. Okay? So like any piece of software, in a way, machine learning system also has a life cycle. And you have to keep tending to it, making sure that it stays relevant, if necessary, going back and redoing it, or even better, and as increasingly the case these days, making sure that the learning is happening online. Every day you're adapting the model, or every week, or every month. Okay? So the key point to remember here is that machine learning in practice is a cycle that has many steps. We're now going to zoom in on the one step in the middle that's very well understood, but bear in mind that the others are there as well. Okay? The other reason, of course, why we can teach learning models, but not the other parts so much, is that learning models, there's a very general set of techniques. Many of these other parts are very domain specific, right? It's very, there's a number of things that you can say, for example, about how do you deploy systems, but really it's going to be dependent on your particular domain, right? The same with things like data cleaning and data formats and whatnot, right? The bang for the buck of trying to teach you stuff like that is much lower. So we're not going to do that here. We're going to focus on the high-value things, but it's very important to remember that those things are there as well, and you're going to have to deal with them if you want to do successful machine learning in practice. Okay? Questions about any of this? All right, so very good. Let us take a break. It's 7:54. Let's take a 10-minute break and reconvene at 8:05. Okay? We'll generally be doing this every week. We'll take a 10-minute break roughly in the middle and then do the second part. Okay? So see you back here at 8:05. All right?